Hello and welcome to today's Explainer. I am your host, and as a senior examiner and subject specialist, I have literally sat down and graded thousands upon thousands of Cambridge mathematics papers over the years. I mean, stacks of them. And because of that, I've seen exactly what separates the top-tier students, the ones pulling in those flawless scores, from the rest of the pack. Listen, let me tell you a secret right up front, okay? The difference between getting a B and an A star in additional mathematics, specifically if we're looking at syllabus 0606, rarely comes down to just natural, raw mathematical genius. It almost always comes down to how well you understand and execute specific structural formats. Today, we are focusing laser-tight on logarithms. When you sit down in that exam hall and you're asked to combine a complex expression, like the ones we'll look at today, into a single base 10 logarithm, or maybe convert a really tricky base over to a natural logarithm, there is a very specific, automated pattern that we as examiners are actively looking for. It's like a giant puzzle, and we want to see if you know how to put the pieces together in the exact right order. So we are going to act like robot engineers today. We're going to completely program your brain for efficiency. We are going to give you the exact step-by-step methodology you need to master this topic and secure every single mark available.
Okay, let's dive right into this. Here is our structural roadmap for today's explainer. We'll start with the challenge, move straight into the strategy reveal, cover the transformation, jump into an interactive workshop, and finish up with the final system. Quick and easy.
Section 1. The challenge. Analyzing student pitfalls. Right, to truly understand how to win at this Cambridge exam, we first have to look at exactly how students lose. Let's introduce two archetypal students that I see every single year without fail in the exam hall. First up, we have Alex. Now, Alex works incredibly hard, studying late into the night, practically living in the library. But Alex's approach in the exam is to completely overload the paper with raw mathematics facts. When Alex sees a logarithm question, panic sets in, and Alex will literally write down every single logarithm rule they can possibly remember. Product rule, quotient rule, power rule. Just throwing everything at the wall and hoping the examiner will kindly pick out the right answer. There's absolutely no structured analysis. It's just a data dump. Then on the other hand, we have Sam. Sam is quick, Sam is incredibly fast at calculating in their head, but Sam rushes. And because Sam is rushing like it's a race, Sam completely misses the specific command word requirements hidden in the question prompt. They might solve for a numerical value when the question specifically asked for a single logarithm expression. Looking at Alex's and Sam's approaches side by side on the paper, you can clearly see the fatal flaws. And honestly, you can see the red pen marks multiplying. Alex gives us a page of messy, unconnected rules that lead nowhere. Sam gives us a final answer that might be mathematically true in a vacuum, but doesn't actually answer the specific prompt. Both of these approaches fail spectacularly to meet Cambridge's assessment objectives. You see, Cambridge Additional Mathematics isn't just testing if you memorized a list of rules from a textbook. The syllabus clearly emphasizes that top-performing students must exhibit connected, conceptual understanding that is completely transferable to unfamiliar contexts. You need logical, structured reasoning. The whole assessment framework prioritizes analytical depth over superficial breadth. Neither Alex's panic dumping nor Sam's speedrunning demonstrates that required depth.
So, what does this all mean? It brings us to a massive question that we really need to unpack. Why do intelligent, capable students find evaluating mathematical evidence and drawing the correct conclusions so incredibly hard under exam conditions? Why are easy, guaranteed marks constantly lost on logarithms year after year? Well, it happens because students are looking at the paper through the lens of a student who is just trying to survive the next 2 hours rather than looking through the examiner's lens. And that is a huge paradigm shift. An examiner is looking for systematic processing. We are looking to see if you can take a complex string of data, deconstruct it calmly, apply the relevant mathematical principles, and present it back to us perfectly structured. If you're just trying to survive, you rush. If you think like an examiner, you process.
Now, what's really interesting about this slide is that these two specific formats are the ultimate test of that systematic processing we just talked about. Take the first one on the left, 3 plus 2 log p minus log q, and you have to format it as a single base 10 logarithm. To an untrained eye, that looks like one math problem. But to an examiner, this is a gauntlet. It's a test of 3 simultaneous rules that you have to juggle flawlessly. First, you have to look at that standalone number 3 and know that it needs to be converted into a base 10 logarithm. You can't just leave it hanging there. You have to know that 3 is essentially log base 10 of 1,000. Second, you have to apply the power rule to handle that coefficient of 2 sitting in front of the log p, pulling it up to make it p squared. Third, you have to apply the product and quotient rules perfectly to combine the addition and subtraction into a single, cohesive fraction within the logarithm. It's a lot, right? Then look at the second format on the right side, 1 over log base x of e. This tests your absolute mastery of the change of base rule and your understanding of natural logarithms. You have to recognize that flipping that fraction changes the base, transforming it elegantly into the natural logarithm of x, or ln x. Mastering these specific, fundamental logarithm formats isn't just about getting the right number at the end. It is absolutely crucial because it proves to the examiner that you possess the exact conceptual framework they are hunting for.
Section 2. The strategy reveal, procedural framework. Let's get into the mechanics. Okay, before we continue and reveal the exact framework, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now so you never miss out on these crucial strategy breakdowns.
So, how do we actually transition from just knowing the math in our heads to actually proving it to the examiner on paper? We need a physical, procedural framework to deconstruct the question. We need a systematic way to extract the relevant data to target the cognitive domains of knowledge, application, and analysis. You need a system that acts exactly like a robot engineer, building your answer step by step, brick by brick. Welcome to the procedural framework. Now, you might have heard of the PEL framework in your essay subjects like history or English, but top candidates use a highly specialized mathematical version of it for Cambridge exams. Step 1 is the point. You must deconstruct the command word. Is the question asking you to solve, evaluate, or write as a single logarithm? Those all require totally different endpoints. Step 2 is evidence. You extract the relevant data from the expression. What are your bases? What are your coefficients? Step 3 is explanation. This is the actual doing. This is where you execute clear mathematical notation, applying your log rules step by step down the page. No skipped lines. And finally, step 4 is the link. You verify your mathematical result and present it with the correct terminology and formatting that was specifically requested by the prompt back in step 1. This standardized sequence is your secret weapon. It proves you have systematic mastery.
And here is why this works so well. By using that sequence, you are directly hitting the 3 major assessment objectives laid out by Cambridge for additional mathematics. First, knowledge and understanding. By explicitly showing each step, you show you actually know the log laws, not just that you guessed correctly. Second, application. You show you can apply those abstract laws to the extracted data, like turning that standalone number 3 into log 1000. That is pure application. Third, analysis. You demonstrate logical, structured reasoning to combine all these moving parts accurately without missing a single beat. Remember what we said earlier? The syllabus clearly states that this analytical depth is heavily prioritized over just throwing numbers at the page. When you use this framework, you are literally giving the marking scheme exactly what it demands.
Section 3. The transformation, securing method marks.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries just by changing how they structure their answers. Join them right now by subscribing to at Ace the Exams IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's talk about the real currency of Cambridge exams, method marks. In additional mathematics, marks are awarded for the process and for clear working out. The final numerical answer at the bottom of the page, that is only a tiny fraction of your overall grade for that question. If you make a tiny, silly arithmetic error at the very end, maybe you added instead of subtracted in the final second, but your whole process was flawless, a good examiner will still award you the vast majority of the method marks. But, and this is a massive but, you have to actually give us the process to grade. And this brilliantly illustrates exactly what I mean about method marks. On the left side of the screen, we have a generic, weak answer. The student has just written down a basic log rule and then skipped straight to a final answer. There are massive gaping jumps in logic. If that final answer is wrong, I, as the examiner, have absolutely no choice but to give them 0 marks, because I have literally no idea how they arrived at that conclusion. I can't guess your brilliance. Now look on the right. We have the context-specific answer. Every single step is shown meticulously. They explicitly show the power rule being applied on line 1. They show the number conversion on line 2. They show the quotient rule on line 3. Even if they somehow mess up the final division step, they have already secured almost all the method marks because the examiner can see the logic. This is exactly what the examiner wants to see. This is how you bulletproof your grade.
Section 4. Interactive Workshop. Critical Analysis. Get ready to participate. Let's put you in the hot seat for this interactive workshop. I want you to look at the screen right now as if you were the examiner.
We are going to mentally scan this complex data and identify exactly where a student begins to hemorrhage their marks. But before you judge those sample workings on the screen, let me give you the ultimate cheat code. These are the top 3 mistakes pulled straight from the official Cambridge Principal Examiner reports. These are the things that infuriate graders. Number 1, missing the proper base 10 format. Students will do all the hard work to simplify the expression, but then completely forget to actually write the base 10 notation when the question demands it, or they'll lazily leave a constant floating outside the logarithm parentheses. Automatic mark lost. Number 2, forgetting presentation checks. They do the math right in their head, but write it so messily on the page that the examiner literally cannot distinguish between a base number and a coefficient. If your base looks like a big number, it's marked wrong. Number 3, generic non-contextual answers. They fail to link every single mathematical point back to the specific scenario given in the prompt. If you can actively avoid these 3 traps, your grade will automatically jump up. I guarantee it.
Let's move to the next slide and see how this builds into the ultimate problem-solving sequence. This deconstruct, solve, evaluate cycle is the antidote to those top 3 mistakes we just talked about. Step 1, identify the given information. Literally take your pen and underline or highlight the bases, the coefficients, and the constants in the prompt. Step 2, break it down into logical steps. Don't try to do it all at once. Deal with your powers first, convert your constants second, and do your combinations last. Step 3, solve systematically with your clear, spaced-out notation. Give your math room to breathe on the page. And finally, Step 4, which is absolutely crucial, check for reasonableness. When you get your final single logarithm, take 5 seconds to mentally expand it back out. Does it lead back to the original question? If it does, congratulations, you've just bulletproofed your answer and guaranteed your marks.
Section 5, the final system, automated execution. Let's bring it all together. Okay, so we have covered the major pitfalls, the procedural methodology, the secret of method marks, and the examiner warnings. Now it is time to synthesize all of this incredible information into your final system. This methodology is meant to act as an automated pattern in your brain. When you walk into that high-pressure exam hall and you see a complex logarithm question staring back at you, you shouldn't feel an ounce of panic. You should feel like a highly tuned machine executing a perfectly written line of code. So the crucial point here is that you must follow these 3 immutable rules to guarantee maximum marks. Rule 1, command word decoding. You must never start calculating until you know exactly what the prompt demands. Highlight the verb. Rule 2, framework application. Use our step-by-step procedural steps to show every single piece of working out, explicitly targeting those method marks we talked about. Be context-specific. Rule 3, time management matrix. Because you now have an automated pattern for these common logarithm formats, you shouldn't be spending 10 minutes on them. You should be moving through them efficiently and accurately, banking that precious time for the notoriously harder calculus or complex trigonometry questions that always show up later in the paper.
I really want to pause on this number for a second. 2. That is the average number of grade boundaries our students improve by when they stop doing random, panic-induced math and start actually implementing these specific examiner strategies. Think about what that actually means. Going from a C to an A, or a solid B to an A star. That kind of jump completely changes your academic trajectory and your university options. It's life-changing. But, and it's a big but, it only happens if you take this system and practice these automated patterns consistently with our weekly videos.
So here is your final reminder to take action on your future. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Subscribe right now to Ace the Exams _IGCSE and click that bell. Don't let another exam pass you by while you're still making the same generic mistakes.
I want to leave you with this provocative thought to ponder as you hit your textbooks tonight, right? When you sit down with a past paper, ask yourself, are you just doing the math in a vacuum, or are you actually answering the examiner? Think about that difference. It is everything. Drop a comment below right now with your target grade for additional mathematics and the absolute biggest challenge you are currently facing with logarithms. Our expert team responds to every single comment. Like and share this explainer with a study partner who really needs a wake-up call before their next mock exam. Ace the Exams. Your Cambridge success starts here. I will see you in the next masterclass. Keep practicing.